Okay, hi to all. Now I'm going to start the class in YouTube Live, and I think you are all listening my voice clearly, and all the members must join in the class. You write your roll number and a name to note attendance. Okay, today's topic is very important. Very important topic we are going to discuss. You listen very carefully. And today is the last topic also in the 10th class. Almost the syllabus is going to complete. The topic is atmospheric refraction. It is most important for the board exams. Okay, request your friends to join in the class in the peer groups. Okay, right. I am going to start, and you listen very carefully. How are you all? Krishna Bandra, Priyanka Mato, Chandra Mohan, Poyal, Tia Kunkal. So many members came to the class. My voice is it clear? Thank you. Within 1 or 2 minutes, I am going to start the class. Okay, thank you to all. Going to start the class. Chandra Mohan, thank you. Your voice is clear. Right. Okay. Very good. Let us start. You type, if you have any problem, you can type the message, then I will read, and by that I can answer. Uh, our topic is what? Atmospheric refraction. Okay. Atmospheric refraction. What is atmospheric refraction? And due to that, what phenomena will occurs and what we will see? Atmospheric refraction means what? When light ray moves from one medium to another medium, light bends at the separation of two mediums. This phenomena is called as the refraction. For example, this is the medium, this is the boundary which separates the two mediums. It is a boundary, and above this we can take as the one medium is there. This is a boundary, and now there is a one light ray which started at here, like this it is incidenting, and this is the medium 1 and this is the medium 2. When light ray moves from one medium to another medium, it cannot go in the straight, it will bends. This bending phenomena is called as the refraction. When light ray moves from one medium to another medium, at the separation of two mediums, light will bends. This phenomena is called as atmospheric refraction. Okay, it is a refraction. What is atmospheric refraction? Refraction means what we know, that is bending of light. When refraction occurs, when you will get the refraction? If light travels from one medium to another medium, refraction occurs. If light travels from one medium to another medium, then refraction occurs. You see here, but atmosphere means only one medium, that is air. Atmosphere means air only. Air is one medium we will take, but even though at some places the air density is more, at some places air density is less. That's why the air also act as different mediums, and part of air will act as one medium, part of other air we can act as other medium. If you split the air into different mediums, atmosphere into different layers, if you divide the, for example, this is the earth, this is up to here atmosphere is there, you divide the atmosphere into different layers like this. You divide the atmosphere into different layers, and now different layers have will act as different mediums, because high density will act as at the less, here density is more, refractive index is more, it will act as denser medium, it will act as rarer medium. If you compare these two, high density at the low and low density will be at the high. You know that lower density will is the lighter, that lighter air will be at the top, higher density at the bottom. That means if you go down, density of the air will be increases. Okay, density of air will increases. That means what happens at here, if you take this medium, it acts as rarer medium, and this medium will act as a denser medium if you take the two parts. Why? Light air will be at here, the air with more weight will is at here, right? This is lighter and this is the heavier. Heavier will act as denser medium, lighter will act as a rarer medium. Okay, I will give the clarity, and I will explain again what is atmospheric refraction and how it will occurs and what is their effects. Clearly I will explain, you listen very carefully, and some more clarity we will get within fraction of seconds. Okay, I'm continuing. What is atmospheric refraction? First I will write, that is the refraction of light. Refraction of light by the refraction of light by the atmosphere. Diffraction of light by the atmosphere is called as atmospheric refraction. In the name only it is there. Refraction occurs due to the atmosphere. Diffraction of light by the atmosphere is called as atmospheric refraction. If you clearly, if you want, when the light passes through the different layers of when light passes through different layers of atmosphere. Okay, then refraction takes place. Then, because different layers of atmosphere will act as different mediums, generally the refraction takes place when light moves from one medium to another medium. But the atmosphere is the air, it acts as one medium, even though, okay, it acts as one medium, even though due to the difference in the densities, different layers of atmosphere act as different mediums. That's why refraction takes place while going from one layer to another layer in the atmosphere. This is called as atmospheric refraction. And now, what is the effect of this atmospheric refraction? Due to the atmospheric refraction, we will see applications of atmospheric refraction now. Okay, applications. What we observe due to the atmospheric refraction. Applications of atmospheric refraction. Atmospheric refraction. I will explain clearly, you listen. The first one is the twinkling of stars. Twinkling of stars due to the atmospheric refraction occurs. Second application is that advanced sunrise and delayed sunset. Delayed sunset. Okay, these two are the applications of atmospheric refraction. Let us discuss about the first one. What is this? First one is the what? Twinkling of stars. Twinkling of stars. Twinkling of stars what? Twinkling means what? Twinkling of stars means stars sometimes appears as brighter, sometimes appears as the faint, okay, with less brightness. What is the reason? Sometimes you see in the night time, if you will observe the stars, sometimes it appears with more brightness, sometimes it appears less brightness. That is called as the flickering or the twinkling of stars. Then why it will happen, I will explain clearly. You listen it here. This is the earth, okay, earth surface. Earth surface, and one person is standing on the earth surface, okay, and he is observing the stars. This is a star, let us consider. It's a star. We will take it as a star. And this from the star, starlight will starts. Okay, from the star, the light will starts. And the light is traveling through the different layers of atmosphere. For example, this is the atmosphere like this. You take the different layers of atmosphere. And when we will see the different layers of atmosphere like this is atmosphere. And atmosphere different layers, I am writing it here. When you will go down, okay, refractive index increases, refractive index increases, and density also increases. That means higher density air is at the bottom. Higher density air is at the bottom. Okay, this layer has more density. This layer has more density comparing to this layer. This is act as denser medium. This will act as rarer medium when you will compare. When you will compare any two mediums, the upper one will act as rarer and lower one will act as denser. Why? What is the reason? Because here the density lighter one is at the top. Okay, light air is at the top, and generally, what happens? The light air will be at the top and heavier and high density air at the bottom. High density means denser medium. Like this, The light which is emitting from the star, it passes through the different layers of atmosphere. While passing through the different layers, it will bends, and finally reaches the person. That means it cannot go in the straight line at here. It will while passing through the different layers of atmosphere, and it will bends, and the light will bends and it travel like this it will travel. If you will do the extension of this light ray, for example, the light is reaching it here like this, you do the extension of this light ray. When we will do the extension for this, we will get like this. Actually light should travel in the straight line path, but here it is not traveling in the straight line. When you will do the extension for the light ray, then we will get the like this. And then this is the straight line. When any person sees the star will appear set here. That means what happened? This is the actual position of the star, actual position. But when the person sees, when this fellow, when this person observes the star never appears at here. The star never appears at its actual position. It appears at here. That means the star appears little above than actual position. This is the apparent position of the star. Why star appears little above? Why star appears little above than actual position? Okay. The reason is that is due to the atmospheric refraction. What happening at here? When the light passing through the different layers of atmosphere, it will bends towards the normal. It will bends towards the normal. And when it will bends towards the normal, I will draw the clear diagram at here. This is the clear picture you see. The light is appears to be, actually the light is coming from, once again I will explain. You listen very carefully. This is the original position of the star. When the starlight is passing through different layers of atmosphere. When the starlight is passing through the different layers of atmosphere, when the light ray is moving from rarer to denser medium, this is the rarer and this is the denser medium. It cannot go in the straight like this. It can bend towards the normal and bends and finally reaches the person. Due to the bending, this light ray is appearing at here. If you do the extension for that, then it is going to here. That's why in the straight line where the straight light ray reaches the person at here, and there the object will be appears. Okay, and this actual star never appears. This will appears. Its image will appears. That means the star appears little higher than the actual position, right? And why it is happening? Why it is happening? Because of atmospheric refraction, because of bending. If the light will act as one medium, you take the screenshot and I will note. I'm going to rub the left side and I will explain clearly once again. This is the earth, this is original star, and this is the person. And the light is, for example, this total air is acting as one medium. One medium. Then light never bends, light will go in straight and reaches the person. Then the light is coming from here only, there is no problem. No bending. Okay. No bending, light is starting. Then actual position is this one. And the star also appears at the same position because air acting as one medium. If air acts as different mediums, if air acts as different mediums, then this star will be appears like this. Light never goes in the straight line; it will bends. Then it cannot go in the straight line because of refraction. It will bends. Like this, it will passes. It cannot go in the straight line. Then when we will do the extension for this light ray, when we will do the extension for this, when we will do the extension of this letter which is reaching the eye, if we do the extension of that letter A, then it is meeting, it is going to this point, then he will see the star at here, right? Instead of it here, he will see it here. That means the star appears slightly above than the actual position because of atmospheric refraction. This is the thing. Actually, what happens, for example, you see in the real life also, we will see that, for example, I will give one example. For example, this is a hot air, hot, this is the flame, okay, and this is the air, air above the flame. What happens? The air which is getting the heat from here, okay, this is the air which is gets the heat and it will go start to the top, okay. This air will goes to the top, and now why it will goes after getting the heat? What happens after getting the heat? This will goes to the top. Why? After getting the heat, it will the layer which is above the flame, it will expands, volume increases. Expand means volume increases. Volume increase means density decreases because density equal to mass by volume. Density is equal to mass by volume. When volume increases, density decreases, it will become lighter. Then hot air will rises up. Hot air will be rises up, and the cool air goes down. Then due to that, what happens it here? When hot air goes up, the air densities are changing it here in this region. If you see any object it here from here, through the air which, whose density is changing, floating air, the hot air is which is going. Then due to that, what happens? This position of at one time it appears at here, one time it appears at here, one time it appears at here. Like this, the why it will appears like that? Because of change in the medium. Because of change in medium. While the air which is above the flame, it gets the heat and it will goes up. Due to that, the variations in the density of atmosphere changes. That's why variation of density in the atmosphere occurs. Due to that, the position of the object is changes, and that is called as atmospheric refraction. That is due to the atmospheric refraction. Twinkling, this is the reason why the apparent position of the star is higher than the actual position. So what is it? Apparent position. Apparent position of star slightly slightly above actual position. Slightly above actual position. Why? Because of atmospheric refraction. And why twinkling of stars occurs? Twinkling means what? One time it appears with more brightness, one time it appears with less brightness. What is the reason for that? That is, for the more and less brightness, the reason is that you see here this figure. when this star will act as point size. This point size object, I say this is moving like this from the light. Star appears with point size because it's at long distance. That's why it appears point size. From that lighter started here, it passes through the several layers of atmosphere with the bending, and finally it reaches the eye. Sometimes more light reaches the eye. If atmosphere changes, always atmosphere changes, density changes, and due to that bending of the light also changes. Due to that, one time it more light reaches the eye, one time less light reaches the eye, one time light does not reaches the eye. That is the light which is emitting from the star. If it reaches the eye, the star appears with more brightness. If the light which is emitting from the star, if it not reaches the eye, then the star will appear dim like this. The if the light, if the due to the change in atmosphere, okay, if the amount of light entering into the eye changes due to change in atmosphere, due to change in atmosphere, the amount of light, the amount of starlight, the amount of starlight entering into the eye, entering into the eye changes with the time, changes with the time. Okay, if one time more light enters into eye means the star appears with more brightness. One time less light appears, less light enters into your eye means star appears with less brightness. Okay, and this is the reason, this is the reason for twinkling of stars. Okay, twinkling means what? One time appears with more bright, one time it appears with less bright, one time not appears. If the light, more light reaches the eye from the star, then you see the figure. More light reaches means it appears with more brightness. Less light reaches means less brightness. Not reaches the, not reaches means star not appears. That means it is depends upon the atmosphere. One time light may be bends in different direction, it cannot reach the eye, right? Then like this is the reason for the twinkling of stars. That means due to atmospheric refraction, due to atmospheric refraction, two things will happen. See, in the twinkling of stars, apparent position of the star is greater than the, higher than the actual position. Star appears little above than the actual position. The second one is twinkling of star also occurs due to the atmosphere, atmospheric refraction. This is one application of atmospheric refraction. And let us go for another application. And for that, that is advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. That are the two applications, right? And now let us see. Let us go for the one more application. Before that, one question I will ask. Okay, stars are twinkling. Why planets are not twinkling? Planets are not twinkling. Is it right? Why the planets are not twinkling? Okay. Can anyone type the message? Why planets are not twinkling? Why planets not twinkle? Only stars will twinkle, but the planets are not twinkling. What is the reason? Why? Why the planets are not twinkling? Okay. The planets not twinkle. Planets not twinkle. Why planets does not twinkle? Because planet is the big size. Planet size is more. Not planet size is more. The planet is near to the Earth. Planets are closer near to the Earth. They can take as they can consider as multiple point size image, multiple point size objects. Okay, the variation of light by different point size objects, different parts, different parts can be nullified, right? Due to that, the planet will not twinkle. What happening at here? Actually, the planets are big size. Planets are bigger means the planets are closer than the stars. Stars are very far distance. That's why they are appearing little small. But the planets are near to Earth comparing to the stars. That's why they have appears as big size. When they appears at the big size, what happens? And for example, you take them as some small parts, and light coming from each part. Okay, right? If it will not reaches, then other from other part it may reaches the eye. Like this, there are many parts are there. If one part light not reaches means the light from other parts maybe reaches. That's why it cannot twinkle. Okay, right. Next, within 5 or 10 minutes I will close. Oh, next second application is what? The second application is advanced sunrise. Advanced sunrise. Advanced sunrise and delayed sunset. Delayed sunset. Advanced sunrise and delayed sunset. What is this? I will explain very clearly. You listen it here. Within 5 minutes, I will close the today's lecture. This is the Earth, and this is the Earth atmosphere. And when you will see the sunrise, when you will see the sunrise, if the sun is comes above the horizontal, for example, here one person is there. Here one person is there. If the sun is at the horizontal like this, if sun comes above this horizontal, then we say that the sun is rising. And then for that, sunrise means sun should be above the horizontal. For example, here the sun is there. The sun from the sun the light started. Okay, sun is just below the horizontal. This is horizontal now. Sun is the below the horizontal. Then at that moment the sunlight will start at here, and it passes through the different layers of atmosphere. When sunlight passes through the different layers of atmosphere, okay, sunlight started at here. Listen carefully. This is the sun is below the horizontal, but he should not appear now. Sun is the below the horizontal from the figure. Sun is below the horizontal. You see this sun is at here. Sun is below the horizontal. He should not appear. But what happens at here? If you take the light ray from the sun, the light started at here like this. It is entered into the atmosphere. After passing through several layers of atmosphere, it will bends like this, and light reaches the person. Okay, then that means light will be reaching like this, and we can do the extension of this light ray like this. Light is reaching like this. You do the extension for this light ray. Why the light ray is bending after entering into the atmosphere? You see here, light ray is going straight, but after entering into the atmosphere, it is bending, 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 bending. The reason for the bending is because of atmospheric refraction. Different layers of atmosphere will act as different mediums. Due to that, what happens? The sun appears above the horizon. You do the extension for this. You do the extension of this light ray, which is reaching the eye backward. Then the star appears at here. Sun appears at here. This is the sun location. This is what actual position of the sun. Actual position means sun is below the horizontal. Sun should not appear, but sun is appearing above. This is the apparent position of sun. Apparent position of sun. But actually, the sun should not appear. But the sun is appearing due to the light refraction. Due to the bending, light is coming from here, from the figure. But due to the bending, the light appears at here. Because the light, in like this, the light is reaching. You do the extension for the light ray, then sun appears at here, not at here. This is the apparent position of the sun. Light ray is reaching in the straight. If it reaches, then it appears at here only. Here it is bending. Due to the bending, the light has appears. You do the bending light bend after the light is reaching like this. You do the extension in the backward. Sun appears at here. Means before sunrise only sun is actually at here, but for us it is appears at here. That means before sunrise only. Actually, sun not crossed the horizontal, even though sun appears above the horizontal, right? That means we feel the sunrise is occurred, but sun is actually below the horizontal. Sunrise not occurred. That means uh, sun appears. Sun appears 2 minutes earlier. 2 minutes earlier than sunrise. Than actual sunrise. Than actual sunrise. Actually, sunrise not occurs, but sun appears 2 minutes earlier than actual sunrise. Okay, sun appears 2 minutes earlier, and after the sunset also sun appears. Okay, I am going to erase the left side. Within 2 minutes, I will complete. Don't worry. On the right side also it is rubbed. Next point I am going to give. After the sunset also sun appears due to this atmospheric refraction. That means sun appears, okay, before sunrise only sun is appearing. After sunset also appears. Sun appears 2 minutes after sunset. Actual sunset is completed. But even though sun appears 2 minutes after 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 actual sunset. Why this happens? You see here. This is Earth. Here one person is there, and here the sun is going to set here. This is horizontal. Okay. Actually, the sunset is completed. Sun is at here. Sunset is completed. This is the sunset sun. Actual position of sun. This is actual position. Sunset completed. But due to light passes